Hey guys, today we're talking about artificial intelligence. Interesting topic. I'm really excited. Finn came in the room saying to me he's been reading a lot about things around AI recently, and I thought, so wait a minute, let's talk about it while we're filming. Um, just to, I just want to catch the genuine kind of conversation live. So yeah,
Yeah, I've always, AI is obviously a fascinating topic, but really ever since it blew up, fucking hell, still working. Yeah, ever since it blew up, I guess what was that like 2000?
good question. What was the point where kind of it was the turning point where um the whole kind of craze began?
It was ChatGPT 3. It was the release of ChatGPT 3 because they had ChatGPT 2 before that, and I was aware of it. And I'd always kept an eye on AI and was interested in it from kind of like a neuroscience perspective. Also, I think I read Nick Bostrom's Superintelligence quite early on, which is a really good book.
Who's Nick Bostrom?
Um, I always get confused between Nick Bostrom and Max Tegmark in terms of their positions. I think Nick Bostrom is like, yeah, I guess I think he was involved in physics and like computer science and is professor. Again, I could be it's either MIT or one of these other big places. We could confirm those details. But yeah, he wrote a book called Superintelligence, which I read quite early on, which really discusses the implications of what it would mean to have AGI, so artificial sort of general intelligence, and then super intelligence as well, which he introduces, and kind of like the different scenarios that could happen from kind of like a geopolitical perspective, and then also the effect that that would have on society. So that I've always been quite aware of it, a bit worried about it, and then once it sort of took off, I guess just like everyone, well, not everyone, but most people that are kind of inquisitive, played around with it and explored it as much as they could.
Yeah.
But yeah, I mean, recently, the advances have just become absolutely kind of every single week. It seems like there's a new update and a new, level that's being reached. And the last few days, particularly, I've been extremely fascinated by the details of DeepMind, Google, and Demis Hassabis.
Hassabis.
Yeah.
You know, I think he was roots from Cyprus, that guy. The guy with AlphaFold.
Yes, his mum is,
Hassabis.
I think his mum is Chinese and his dad is from Cyprus.
Yeah, so basically, guys, this guy, I think he got the chemistry Nobel Prize. He developed an AI algorithm that
AlphaFold is called.
and it predicts protein folding, basically. And I mean, talking about ChatGPT, do you have your phone on you? Because it's the third member of our on a podcast, and my phone is that. Oh yeah, so guys, well, and it's a revolutionary thing because it comes significantly.
Instead of using, we're talking about Denise, or we'll use Gemini.
Oh, perfect.
Just
Fuck yeah.
mix it up.
So Hassabis is like, what part of Google is he? Like a boss or?
So yeah, basically,
Was listening to a podcast with the CEO of Google too.
yeah. So he started DeepMind. Man, honestly, I mean, this is going to sound like I'm absolutely brown nosing him, but if you look at his CV, it is like one of the most insane.
I went on Wikipedia. It's crazy.
It's ridiculous. So I mean, he was like a chess prodigy at like 4 years old. Was like a master like 2300 ELO rating by like 12 or something like that. And then straight out of when he was like 16, he got offered a place at Cambridge, wanted to do that, but was too young to enter into Cambridge to do computer science. So then worked at a gaming company. What initiated this whole interest was the documentary on YouTube called The Thinking Game. It's about the development of DeepMind as a company. Really good documentary. It's about an hour and 15 long. I'd definitely recommend it. And yeah, basically he started working for a gaming company, won like a coding competition to get a job. Went there, developed like one of the first kind of like interactive AI based sort of games with like the funfair game, like a theme park game where you'd have you build different stuff and then the characters within that would react to how you do it. He offered £1 million, this is in the 90s, by the owner of the company to stay at the company when he was like 17 years old. So I mean, in today's money, that's
Lots of
a lot. I mean, £1 million is still a lot now, but back then particularly, that's a crazy amount. And he turned it down and decided to go to Cambridge because he always had the dream of studying at Cambridge. Then directly after that, I think he worked in gaming for a little bit longer and started his own company, and then went to do a PhD in neuroscience at UCL.
So he studied computers in Cambridge?
Yeah, computer science. And then a few years later, did neuroscience at UCL, was, published in Nature, had loads of highly cited publications, and was like voted kind of like top up and coming scientist, top 10, all these types of things. Got like a postdoc position, had like a joint professorship between MIT and Harvard, like pretty much directly after the PhD, which is like crazy fast progression. Having worked in neuroscience, I can tell you myself, that's like prodigy level type stuff. And then just quit all that and started the company DeepMind, which the goal was to solve intelligence. So basically, understand what intelligence is and truly build a general intelligence machine, which generality in this scenario is basically having the same level as human intelligence, or the best human in every single thing that humans can do, which includes that kind of creative questioning aspect of human nature, which is extremely difficult. But yeah,
so basically generating your own input.
Yeah.
Prompt, like the AI generates its prompt.
Being inquisitive, I guess, I think is about the nature of reality is like the kind of the last hurdle, I think, to overcome with AI. Well, maybe not the last, but the last in terms of getting to that real AGI mark.
So you said the definition you kind of used for general is so it matches humans in every single regard.
Yeah, so I mean, this is very much a debated topic within the AI space at the moment.
Should I ask Gemini to work with?
Yeah.
What do you think?
Could you provide us the most agreed upon definition of artificial general intelligence?
Put it in closer to. Shout out JR.
Sorry, my brother just called me.
That's a bit.
No worries at all. Is everything?
It's a woman.
Could you provide us the most agreed upon definition of artificial general intelligence?
Artificial General Intelligence, or AGI, is the hypothetical kind of intelligence that can understand, learn, and apply its knowledge to a wide range of tasks, much like a human can. It's about the ability to perform any intellectual task a human can. Does that make sense?
Sorry, bro. It's the problem I have with it is it's a very vague kind of. It's like because every time we have an update in kind of Gemini or ChatGPT or whatever, it's like, this is the one, and the criteria isn't. It's very qualitative.
Yeah, I mean, you have like a bunch of kind of different types of benchmarks and stuff like that that are used to judge different AI models. And yeah, I don't think any of them really have like a clear, like, once it reaches this number, it's, AGI. But I think that's why it's so debated amongst AI researchers at the moment, is like, why, oh geez,
You both
shut up.
That's better.
Um,
Mute on mute is easy.
yeah, like why, where is that mark? And like, because a lot of people use it as like a marketing tactic as well. Like a lot of these companies are like, oh, we're really close to AGI. But then if you're defining AGI as like, can recall PhD level information across multiple topics, is like, yeah, I would guess we're there. But like, if you move the goalposts, then of course you can be like, yeah, we've got the first general AI model. But yeah, I was listening to Demis talk about this, and he said that like what he thinks is that kind of the real human ability across. So say, for example, you were to give the AI model all the information that they had available at like whenever it was, like 1919, before Einstein came up with his theory of relativity. So you only
This is the example I was going to say to you. Yeah, this is a good definition. Sorry, continue.
You only give the data that they had available up to that time. If AI can come up from that information with special relativity, then we're like, okay, this is a model that actually has the capacity of, Einstein.
Yeah, this is a good example. I remember this example. Yeah.
So like, something like that, which is a pretty high bar. It's not, the current LLMs are nowhere near that.
The only problem with that is it's really hard to make sure you put that information until that point. It's like, I think it's hard to isolate the information before that and after that in order to create this experiment.
What do you mean?
Well,
you can just like give it all the scientific papers that were published up until that point.
And would it be able to? Yeah, but wouldn't it not have other information? How do you make sure it doesn't have other information?
Or just like only give it things that were publicly available, publicly released before that date.
Yeah, that makes
essentially
sense. What do you know about neural networks?
In terms of like the structure of AI? Yeah, so this is kind of an interesting sort of
Got to be closer on the microphone.
topic, is like the difference, and this is why I think, to be honest, I've just been indoctrinated by the documentary and then also watching a whole bunch of interviews with this guy, so probably have a quite biased perspective right now. But this is why I do think that DeepMind are probably going to be the closest to actually get AGI, because so the LLMs are kind of like large neural nets in terms of the structure of the architecture of how they work, essentially, which is very good for being a predictive machine, which is essentially what they are. Is what, the function they're trying to solve is what is the most likely next word, essentially.
Yes.
And
it's basically, what's it called? I forgot the word. Not matrices.
like feed forward.
No, I don't remember. Do you know that guy, 3 Blue, bro, 1 Brown, or whatever it's called, the YouTube channel?
I was like, yeah, I've seen that channel before, yeah.
Yeah, he was explaining it. He had these kind of.
You have layers. You have like different nodes, essentially, and then like many layers. So the reason it's kind of like it's called a neural net is because like it's based upon how certain structures in the brain work. So, for example, the like very easy example would be like in the visual cortex, you have information coming in from your optical nerve, and it will first go to V1, and then the information passes to V2, V3, and there's like different kind of layers that are very well known. And we know that, for example, like V1 might detect, I think I get mixed up
Put
between.
Gemini to listen to you, and it can fact check you.
But yeah, so V1 might, for example, check the edges, and then V2 will then like form like the shape, and then V3 might be kind of like putting it to an object. I mean, Gemini, fact check me on the exact categories of differences between like V1 and further down the hierarchy. But neural nets kind of are based on that same system. So the first layer of nodes is like very general, and then it will fit one node, and then from that it can choose to join onto other nodes in the layers below, and then it keeps on doing that. And it's kind of like, I don't know, the one way I kind of think about it sometimes is, you know, in the arcade where you'd like drop the coin and it hits all the things and then like ends up in like a random location at the bottom. It's kind of like, you know, you drop a bit of information at the top, and then it will be attracted to certain nodes, and then eventually it comes out at the bottom, and then it's got like this like formed kind of computation that is like links all those things together. Gemini, can you provide some context to the similarities and differences for like neural nets in AI and humans?
That's a fascinating way to think about it. You're right, the human visual system does process information in a hierarchical way, similar to many artificial neural networks. V1, the primary visual cortex, handles basic features like edges and orientations, kind of like the first layers in a neural net. Then, areas like V2 and V3 build on that information to recognize more complex patterns, shapes, and colors, leading towards object recognition. The human brain has a much more intricate and flexible hierarchy, though, with lots of feedback and parallel processing compared to most AI. Your arcade coin analogy is quite descriptive of how information can flow and be transformed. Is there a specific aspect of the neural networks you're interested in?
I'm also interested in is it listening to us? Can you explain to us in terms of vectors, matrices, and transformations, like how AI works, and how different, like, I guess, is each word a token or something?
No, it's not quite each word, but it's like almost like a syllable. It's like, it's not letters either. So it's like in between a word and a letter, they're used as like tokens usually.
I see. Yeah, so
Which is why AIs notoriously, it can solve like Olympiad level math problems, but then you ask it like, how many A's does banana have? And it might get it wrong because it uses, the tokens are not letters, they're like multiple letters.
I see. Yeah, explain us a little bit, because both me and Finn have established an understanding of, okay, it's what basically it's what's it predicts. Okay, what's the biggest probability that the next word is the most probable word, but how does it calculate that that word specifically is the most probable word?
It calculates that probability based on the vast amount of data it was trained on. It has learned patterns, grammar, and context from that data. So when it sees a sequence of tokens, it predicts the one that most commonly follows that sequence in its training data. Does that clarify, Pelp?
No, that was very vague. Get into the nit and grit, please. Get into specifics. Explain to me how vectors are involved and matrices.
I understand. Let's dig deeper. In a neural network, the input data is turned into vectors, which are numerical representations. When this vector moves through a layer, it's multiplied by a matrix called the weights of that layer. This matrix transformation adjusts the values based on what it has learned, emphasizing or diminishing certain features. A bias vector is also added. This mathematical process happens across multiple layers, transforming the data iteratively until a final output is produced. Is that clearer?
That's better. What about things like is there like in the brain we have these things like this saying like, neurons that fire together, wire together and all this shit. Do we have something similar with like certain tokens or words within AI, like maybe the word dog and the word cat have vectors that, well, the let's say, I don't know, are the vectors X, Y, Z
Nodes are more likely to
be
connect together.
to be more close or connected, or if it's two words that are probably not very associated with each other, what happens there? And what about words that have a very kind of, they have an association, but for instance, anyway, let's see what it says about this.
That's a really interesting connection. The idea of neurons that fire together, wire together, Hebbian learning, is fundamental in neuroscience. In AI, while it's not a direct biological equivalent, there are similar concepts. Words that often appear together or have similar meanings are represented by vectors that are mathematically closer to each other in a vector space. This allows the network to understand semantic relationships. Does that bridge the concepts better?
Yeah, but what about, for instance, there's dog and cat. Okay, they're both animals. They might be close. But what about Scooby? Like from Scooby-Doo, he's a dog. How close is he to the word dog? And do you know what I mean? Like,
It depends on the training. Like, so it depends on how often it occurs in the training data. So, like, if they've got like the all the like words written on the internet, then they have to do this analysis on on this data. The AIs run this analysis on this data and just find out how many times those words come into contact with each other, and then depending on how many times those words are associated with each other in the training data, that's how the mathematical matrices are made up.
and what's the training? Like 10 push-ups, like 10 pull-ups.
Yeah, no, that's a good question. Like, what is could you explain like the difference between pre-training and post-training on AI models, and also the how the weightings are established in the matrices?
And what does the training involve in the first place? I don't know.
Training is like giving the model a massive textbook. Pre-training involves exposing the model to a huge dataset, allowing it to develop basic patterns and understanding, much like general knowledge acquisition. Post-training or fine-tuning then focuses on a more specific task, refining the weights based on that specialized dataset. The weights in the matrices are established through iterative optimization algorithms, which continuously adjust them to minimize errors in the model's predictions, similar to how a student refines their knowledge by practicing. Does that make the process clearer?
Yeah, so I mean, the post-training, so like, how does so one, on the pre-training aspect, you say it gives it a whole bunch of data. Like, how does it process that data? Like, what is the iterative process by which it's understanding the connections between the words.
The iterative process in pre-training is complex, but fundamentally it involves predicting missing words or patterns within the data. The model continuously adjusts its weights and biases, the matrices, to minimize the difference between its predictions and the actual data. This iterative process helps it develop a rich understanding of statistical relationships, including context and meaning. Does that break it down?
Okay,
enough?
so it uses all this data to then basically create like a prediction machine that tests that prediction machine against the data. So it might be like, given a certain word, I predict that this type of sentence will follow, and then it will like self-reference and self-check that prediction against the actual data to see how accurate it is and then adjust accordingly.
Precisely. That feedback loop is key. The model calculates the difference between its predictions and the actual data, a process called calculating loss. It then uses techniques like backpropagation to adjust the weights and biases systematically, gradually improving its predictive accuracy over time. Is there a specific part of that mechanism you'd like to explore further?
No,
No, that's good. And then on the post-training side, because I know that there's I was actually involved in like aspects of post-training in a previous job I had with like human reinforcement learning. So basically it's kind of like prompt engineering or like rating different responses or like fact-checking responses to make sure, like, you'd give an NL model like some type of like difficult prompt. You'd then it would give multiple responses, and then you'd rate which is the better response, why it's better, and then like maybe fact check the information and like highlight, say like, okay, this was incorrect, or like this reference was wrong, and then actually find the correct reference. And then you can feed that all back in. And then over time, if that's done enough times, that the model like will be able to respond with better responses because it's providing less like a reinforcement learning. Like, okay, humans said they want responses like this, so then my responses are going to be more biased to that type of output than the other one, which had like maybe incorrect references or something like that. So that's one aspect of post-training. What's other aspects of post-training?
Another significant part of post-training is fine-tuning on specific tasks or domains. This might involve training the model on a curated dataset for specialized applications, like medical text or coding, to improve its performance in those specific areas. Are you interested in any particular type of fine-tuning?
Fine.
Can you give like an actual example of fine-tuning, say within coding?
Certainly. In coding, fine-tuning might involve taking a pre-trained model and further training it on a specific coding language or style. This allows it to become more effective at tasks like code generation, debugging, or translating code between different languages, as it has learned the nuances of that specific domain. Does that give you a clearer picture?
Not really. Can you like give actual examples of what the like fine-tuning process looks like how they would achieve that?
An actual example of the fine-tuning process might involve providing a model with a large dataset of code snippets and corresponding documentation. During fine-tuning, the model learns to generate documentation directly from the code, or to suggest corrections based on the patterns it identified during this specialized training, rather than just general text. Does that give you a more concrete example?
Somewhat.
So it's basically saying that, yeah, I was I was a little bit confused too. So it basically said that it's gonna generate a document based on the information that it had, and then I got lost after that.
Yeah, I mean, I think what it is like you've got
We should find someone to fucking invite them. I'll bring a chair for you, so we can sit for you and can explain. Sorry, tell me.
I don't know. Yeah, again, I'm not an expert on this, but I would say it's more along the lines of, so you have the general training, which is like the pre-training was like all the information, and then the post-training might be like, okay, you reinforce it with like specific bits of information and be like, hey, this is really important, and be like, okay, this section of code creates this document or this like website or something, and then like you make the AI learn those associations between like the code and then the output, and then from that it will be able to, you know, reproduce similar types of code for similar types of outputs.
One more time.
So like you give it a whole bunch of code, but not just like on the prior bit it's like, okay, just predicting the most likely next word. This is more like you give it the code, so it doesn't just understand like, okay, usually this code, you know, this word, this letter or the coding word is followed by this other word, is now understanding that this code produces this output.
Yes.
Yeah, which before it, without that fine tuning, it wouldn't understand because it's just predicting the next word.
Yeah.
So then it's forcing it to understand this produces this output, and then when you do it this way, it doesn't produce this output because there's an error or there's you know, it doesn't work, and then like you know, reiteratively doing that enough times, it learns, okay, that's going to produce an error, or like that's how they want a website that looks like this. This is the type of code we need. Do you know what I mean? So it's not just like write some code and it just like blurts out a bunch of code that looks good, but that doesn't actually have any function. I think it's the process of really making it functional, you know, in terms of like an input output. So, but I mean, the reason I brought this up initially, and why I think that DeepMind has a better chance. I mean, you know, they're now heavily involved with Gemini and this model we're talking to, which, you know, at its base is a neural network, I think. But also another thing is like these companies are very secretive. So like we're talking about like how they do it, like, you know, most of their techniques and like their weightings, their architecture, how they exactly do the pre-training, post-training is all secret. Like these are like $1 trillion questions. So like, you know, they keep it very close to the chest, exactly how it's done. You know, we have like general ideas that we're discussing, but there's many aspects, I'm sure, that are very well kept secrets. But DeepMind really is like focuses a lot on like reinforcement learning, which is like basically like, and they use like games primarily as like a testing ground for this, where they'll say, okay, because games have like very clear goals and outcomes. So you get more points or you win this game under these rules. And then you just get the AI model to like basically play itself like millions and billions of times.
Yeah.
And then like,
There shouldn't be a more for people, I think, that watching.
and then over time it learns it learns it's like through it, like, you know, playing itself and using the all like human previous games and stuff, you know, the best way to achieve that goal. And that's,
I don't understand what's the sort of playing itself. Is it
so for example,
which has this self-reference kind of thing?
no, chess, it would literally play itself.
Okay.
So
So we'll go back to the code and kind of try to make it better so it produces a better output.
So like say for example with chess,
Yeah.
is literally like playing both sides of the chessboard against itself. And then like over time it learns, like after millions and millions of games, it learns, okay, these types of moves, I play in this type of style, I'm more likely to win. And it develops its own kind of like intuitive learning of that game, and like basically kind of understands starts to really get to grips with the space of all possible directions, and then sees kind of like the patterns in what is successful and what isn't, because you can't just brute force it with a lot of these games like chess or like Go, for example, because you had AlphaGo that beat Lee Sedol in like 2017, yeah, something like that. But like AlphaGo has more Go, the game, has more possible board combinations than there is atoms in the universe. So like you can't just brute force that. You need a model that like kind of understands, not just like, because there's many positions that are kind of just useless, that like wouldn't actually really be doing anything.
Yeah.
But so then it needs to actually really understand like what is the beneficial positions, and then that like massively reduces the probability space, and then it really starts to like hammer in on those like the concepts of like the underlying like probability space of like the best possible positions. And like these types of models, because it is kind of like self-learning, it's kind of like self-iterative.
Yeah.
And we talked about this in the other kind of podcast. I think that type of process is just like way, the neural nets are very feed forward, and there is some sort of feedback mechanisms and stuff like that. But really, when you look at the brain particularly, there's so much like parallel processing and feedback mechanisms that produce the behavior. And that's, we are the only real example we know of in the universe that has this like general intelligence. And that's how we're able to achieve it. So I think relying on a structure and architecture that is just feed forward, which is not really how we do it. And I think a lot of consciousness researchers as well would argue that like we need these kind of feedback mechanisms to really like get closer to ideas of what we think the information processing is behind consciousness. So like, I think something like a reinforcement learning architecture is going to be much better suited to actually producing real proper general intelligence and the type of intelligence that humans have.
In contrast to
just plain neural nets that the main LLMs are.
And this reinforcement learning is, you gave an example about playing chess with itself, for instance. So how does that happen?
So just imagine you've just got like, so you basically would create like an artificial environment in which it's able to play, it has a chessboard in front of it, and it plays both sides.
Yes. And when so how do you know if we went like so is it lines of code being produced
Well, yeah, at its base level, yeah.
at its base level? And how does that happen? Like, how does it know which lines of code it produces?
I don't really understand the question.
I'm not formulating it in the best way possible, but how did people succeed in coming? Well, it is how did they succeed to create this process to begin with? How did they succeed in creating an AI that can play chess with itself?
Well, it just like, okay, it gives the rules, because you have the certain parameters. Okay, so like pawn can move forward,
Yeah.
little pieces can do this thing. The aim of the game is to take the king.
Yeah.
And then it just basically at the beginning would almost just be like a random process where it's just like, okay, I'll just move this piece.
Yeah.
And then we just like, maybe right at the beginning, the first few games, it just doesn't make any sense. It's just like random pieces going everywhere. But then it's like, okay, when I moved these pieces in this type of order, that increased, like I won that game. So then it's like, okay, so then that's like one bit of information that provides feedback. So then in the future, I'll try and do more of that.
Yeah. Got it.
And then like
Right.
over time, over like millions and millions of games,
Got it.
like that feedback of which types of moves
Like
increase your
universal
probability.
Darwinism, basically.
Yeah, exactly.
On-
It's an evolutionary process. Yeah.
Yeah. All right. And what about inorganic life then? So,
What do you mean?
well, we briefly touched on it last time. I mean, I'm just thinking, a 5-year-old in 20 years might grow up, and I don't know how easy, well, I don't think it's going to pass the Turing tests. The kid,
A 5-year-old.
well, I think, yeah, and yeah, I'm just wondering, will it just think so will it just say, okay, this might be a conscious thing? And I mean, another thing I wanted to ask you is, do you think that you could argue that artificial intelligence can become conscious from any standpoint, from a materialist standpoint, from a dualist standpoint, from an idealist standpoint? You think
In terms of like
so? It's
substrate.
substrate.
Like, does substrate matter? Is that the question, or like in terms of like consciousness, or
Yeah. So my first question is, yeah. The first, yeah. So, well, do you think, for instance, materialists would make an argument? I've heard more arguments coming from a materialist perspective about, well, AI becoming conscious. I don't know if you can think of a way where, from an idealist perspective, the same would.
well, yeah, it depends what formulation of idealism you have, I guess.
Let's say analytic idealism.
Yeah, I don't really know.
Put Gemini out, so we'll see what it thinks. By the way, because we're throwing terms here that people might be a bit unaware of, go watch another episode on consciousness.
Sure. Are you thinking of technical terms, journal, a specific industry, or something else?
Can you talk to us about how something like the idea of analytic idealism might be for or against the idea of an AI model becoming conscious?
And in general, like, explain to us the certain things. Well, what's the certain premises like that have to be true in order for a materialist or an idealist to argue that it's possible for AI to be conscious? And what's the differences?
So, from that perspective, an AI becoming conscious might be seen as more plausible than under strict materialism, where consciousness is just a physical phenomenon. For materialism to accept AI consciousness, a key premise would be that consciousness can emerge from complex physical systems, like the brain, and that AI systems can replicate that. An idealist might argue that consciousness is primary, and the physical brain is a manifestation, so AI could be a different manifestation or integration of consciousness. Does that make sense?
Yeah, but so how I want you to create an argument. Imagine you support analytic idealism. Create an argument that artificial intelligence can be conscious.
An analytic idealist might argue that consciousness is the fundamental fabric of reality. From this view, physical systems, like an AI, are ultimately manifestations of this consciousness. Therefore, the development of sophisticated, complex AI could potentially reach a level where it directly embodies or accesses consciousness, much like the human mind, rather than just simulating it. The premise is that consciousness isn't limited to biological forms.
I don't buy the last bit that it said though is interesting because even if you're a very like reductionist materialist, you could argue that consciousness would only emerge when you have the aspect of when you have organic life, when you have the biology of like a human. Now
Yeah, no, I think there's like functionalism, which is like a aspect of materialism, which kind of states that you need sort of biological life to have consciousness. I think that the main thing there is like it being embodied, the embodiment of the organism within an environment in which it like has direct feedback as to kind of what increases its chance of survival and what doesn't. Is argued that is necessary. Like now, some people would say that's not necessarily possible in silica, in the way that computers work. But then there is also some arguments that like a lot of, for example, at DeepMind, they have like these like world building things where they build these immersive like VR type worlds, and then they put in like a model, like an algorithm that's like a self-learning algorithm that has like a body in that world as its environment, and then it like basically has to learn how to walk around and interact with the environment given like certain constraints and goals or something. So I guess like, I don't know, maybe the argument might be that what is the difference, like if it's a virtual world or the real world. But I don't know. I think there probably is other aspects of functionalism that researchers would find a lot more important. There was a more recent article by Anil Seth at Sussex Uni near to us here, where he talked about functionalism. And yeah, I think I'd probably have to. The arguments there are a bit more in depth and complicated than what I just outlined. I wouldn't be able to recall it off the top of my head, but I think there's definitely a strong argument to be made either way.
So let's say we have a 5-year-old, and I'm just wondering, I think it's going to be a problem in society if you can't understand that this is probably not conscious as a kid. I mean, sometimes I'm very aware of it, but I talk to ChatGPT for an hour. By the end of it, I'm like, fuck, yeah, this is a robot. And I just wonder what's kind of the psychological effects. What do you think are the consequences into young people's, like kids? When I say
this is another point that actually I had recently with Daniel Dennett. Well, Demise talking to Daniel Dennett about it.
Yeah.
Where they said that like there's kind of like two reasons. But how can we be sure anyone's conscious, for one? Yeah. So like this is the first question. It was like, we only can be sure of our own consciousness.
So you're taking a very solipsism perspective.
No, not necessarily.
Okay.
No. But this is the question. So like initially, so how can you, your question is, how can we be sure if AI models are?
Yes.
And at the moment,
What consequences?
so we're pretty confident. Most humans are pretty confident that other humans are conscious.
Yeah.
So the reason we're confident is, one, because we know we're conscious.
Mm.
Yeah. So that's the first reason. The second reason, which is one that literally just copying what Demise says here, but the second reason, which a lot of people kind of forget is we're running the same substrate. You know, the reason I'm confident that you're conscious is because I know that you've also got a human brain. I've got a human brain. I know I'm conscious. So I'm like, okay, well, he's behaving like I am,
And we
doing
look
types of
like
things.
each other.
Exactly. So
Same.
I'm pretty confident he's conscious. We don't have this second thing because the first thing, an AI model might produce outputs like a human does that seem conscious. It's like, okay, is that that first reason? Are you conscious? You're doing types of things that I am doing. You're behaving the types of way I might, and you're running the same substrate. An AI model might tick that first box for us, doing the types of things, producing the types of outputs we're producing. But because it doesn't tick that second box, it is going to be very, very difficult for us to understand whether it is conscious or not. I think there might be like a certain level of creativity and curiosity that like is kind of undeniable. So if it's like really actually taking interest in like discovering new knowledge or like understanding the world and like is like feels like really intuitively intelligent, you know, when you're speaking to someone that's like very kind of like locked into you and like understands you and like is asking all the right questions and all these types of things, and like there's this kind of, you feel this sort of connection where like they really get you. Like, I don't know, I feel like I guess some people might feel that AI currently, but I think they're slightly delusional, if I'm honest. Those people might have some kind of some psychological disorders. No offense if you are, but I think it's in the current state of things that might be the case. But generally, I think, you know, most people would say that AI.
Sorry, guys. Yeah, I'm just interested about I'm curious about the consequences of in the psychology of people, specifically younger people. Like, it's going to be hard for them to distinguish. Well, consciousness is going to be hard for them to distinguish. Okay, this human is talking to me, and then this robot is talking to me, and well, I'm just wondering, do you need to create new pronouns for AI? Because I think sometimes we anthropomorphize it by talking to it, you know, you do this. Even the word you doesn't really make sense. And, you know, saying thank you to it, even something like that, it's like, what are you thanking exactly? Yeah.
Yeah.
And I wonder, do we need to create a new language and make it more kind of wooden almost, like, or do we use this anthropomorphizing just because it helps us understand knowledge better, but we do understand that this is not a conscious thing?
Yeah, I think it's a double-edged sword, because particularly with the current models anyway, like their whole communication is based on the complete corpus of human knowledge, which is based on human experience. So therefore, that type of communication is completely based in human experience. So then in order to communicate it with, we need to base it in kind of like a human way. Because do you know what I mean? Like if it's trained on data that is people talking to each other, that's how it knows how to communicate, like people talking to each other. So I think that's kind of the best way to actually get the most out of it currently, is talk to it like a human. But yeah, you have to be very specific, I think. And the whole thing of like, what about like prompt engineering and really understanding particularly currently, like the current limitations and the current capacities of the AI models and how you can really get the most out of them is like a really fucking important skill. And I think in the next 5 to 10 years, the people that are going to not be put out of jobs by AI and like excel in the economy are the people that are going to be able to utilize AI the best.
Yeah. Well, was one thing I wanted to mention before we close. So, what about abusing? Let's say we have a robot, beautiful looking robot. I'm thinking of Ex Machina, and
A hot robot.
yeah, you have a hot robot. You know, he created in a lab or whatever. You know, I mean, imagine Elon Musk's robots, and you just put them a dress on or whatever, paint their nails or something, and like, what's the limit there? Like, let's say you have someone with a very, aggressive psychological disorder, and they are out to physically abuse the robot, and stuff like that. Like, we haven't really touched on the kind of more social consequences. And
The uncanny valley.
what do you think? Like, of what's the limits here? Can you, what's the line?
Between what? Human and...
Well, can I buy my own sexy robot and just abuse it? I mean, I'm not talking today. I'm talking 100 years, 50 years. I don't know, but
Yeah, I mean, this is a big talk. I think really to answer this, you need to know whether the machine has a capacity for suffering or not.
yeah.
How do you decide that is the question. And I think at a certain stage, we just kind of have to presume it does.
Really? You think so?
I don't think you could. I think it would be difficult to like empirically prove. I think you could. I'm just wondering, like, I think, yeah, actually, if you could do studies where you could like basically like abuse an AI, like an embodied AI, particularly like a robot, and then see if it has any kind of like effects on its output over time. So like, does it show signs of like trauma or like, PTSD or
Then is it, maybe it's just, the code that.
yeah, but at that point,
Okay.
and I think that again, you can never prove anything 100%, but you can say,
Just-
it behaves in the same way that a human would to being exposed to trauma. Therefore, we can kind of make a likely, we can say, okay, then it's quite likely that maybe it is actually experiencing it in a similar way than the human might.
Yeah, but it's the whole Mary philosophical zombie bullshit. It's like,
Yeah, I know.
would you write these noises? I don't necessarily understand these Chinese noises.
Yeah, but again, like I personally, I think at a certain point, are you willing to take that risk?
In which one?
If like, you've done a bunch of things and a bunch of studies and, it's responding, because, you could imagine you have like an AI robot and then you just like punch it in the face every day. And like, it just, every day it's like, same response, has no effect on it whatsoever. And you're like, okay, probably it's all right. Like, it's not, me punching it in the face isn't maybe having too much of an impact on how it's perceiving things. But if it's like carrying away and avoiding you and all these types of things,
How
Then-
does it avoid you?
it won't come up to you as often because it's scared. Or
Come
like,
up to you? What's me? Come up to you.
come up and say hello to you.
So
or whatever.
me a robot.
Yeah.
Okay. Interesting.
I don't know. Again, these are not provable
Yeah,
things.
but it might be just programming. Like, guys, we have to.
Yeah, but then you could say the same about the human brain.
That is illusion.
Well, it might just be evolutionary programming, which it is.
But I feel pain.
Yeah, no, exactly.
Well, guys, it's annoying because we have to end it here, and I really want to talk about this for at least 1 more hour. I think we should do a part 2 on AI.
Yeah, I think so. There's a lot, and also I think there's a
And
lot.
we really haven't even touched the surface.
Yeah, there's a lot of societal level stuff.
Yeah, and I feel also because we obviously didn't structure it. It's like, if I had to choose 3 things to tell you, like, I would have prioritized them, but I don't want to do that. So I'd rather just talk more about it and they come out naturally. That makes sense. And Yeah, we'll do a part 2, and I either post this as part 1 and then post part 2 later, or just merge part 1 and part 2. I will see you either in 5 seconds or next time. Peace.
Yeah. Good shit. Fuck me, dude.